Hello everyone. So in this video, let's talk about the binary tree post-order traversal. So there can be different type of traversal over a tree. There can be pre-order, in-order, post-order, DFS, BFS. These are generally the different type of traversals over a tree. And it's better that you should know all the type of traversal to traverse over a tree because different type of use cases require different type of traversal. But pre-order, post-order, these are a type of DFS only. So in general, there are BFS and DFS traversal over a tree, and this pre-order in order is generally a variation of DFS. Okay. So in this problem, I'll talk about what is a post-order traversal, and I'll tell you also what is the difference between pre-order, in order, and post. So when I am traversing over a complete tree, okay, we actually have to go in the left sub half of the tree, right sub half of the tree, or we have the node I am on. I'll give you an example. So let's assume that this is some, and I have to iterate over this whole tree. So we'll start from the root node. Then either we have to go to the left hand side, that is one of the options, or we can go to the right hand side, one of the options, or we take the value that I'm on because I have to eventually do some processing on the tree. So I have to like print out the values or do something. So do something means that I am taking this particular node and checking that what is the value inside this particular. So in that case, I am doing some processing, or let's assume printing the value of this. So now we have three types of operation: going to the left, going towards the right, or print. These are three operations that we have. Now, these three type of operations, whatever you do this operation in which order defines the traversal type. If the print is the first part, let's assume if you do first print, then left. If I do first print, then left, then right. So then this is called pre-order because we are, so just understand that there are pre, in, and post. And these three terms depends upon where you are doing the printing. If you are doing the printing first, it's pre. If you are doing the printing in middle, L and R just always keep it, so it's N. If you are doing printing at the last, is, so wherever you are doing printing of the values is the term where this definition comes in. First, it's pre, middle, in, last, it's okay. That's the complete logic for this particular problem. So we just have to do a recursive traversal over this whole tree. And because it's a post order, we have to first do left. We have to first go left, then we have to go right, and then we have to print. Nothing much difficult here. I'll tell you the code part and problem. So we have to print out the postal traversal. So for printing out and getting the answer, we'll just make a vector of variable, not variable, let's say an empty vector of answer, which will keep on pushing the traversal values or like how we are traversing. Okay. We'll call this travel function that we have written, in which we'll pass the root. We'll start the iterating from the very top root node. And this answer is passing by, as you can see, reference, so that I can keep on pushing the traversal path, this answer vector. So as you can see, we have three things. Go to the first. So as you can see, recursive function, recursive traversal. So we'll first go to the left hand side, then going to the right hand side, and then pushing out the value in answer vector so that we get the traversal. Pushing or means like printing, whatever you want, is the actual, you can say, value or place at which we get the answer. So as you can see, this is how we are traversing and printing. That is why it is called post. If I put this value here, then it will be in order. If I put this value here, then it will be pre-order. That is just a simple code change for the problem. And this is the base condition because we are doing recursion. So for every recursive function, we have to have a base condition. So this is the base condition function that if we have no more route to, like no more node to travel to, then obviously we should. So if the route we are landing upon is null pointer, null means that we are nothing to be. So if I just also show you with this example that we have this type of tree. So what we are doing is that we are first going to left hand side. So we'll keep on going to left until there is no left. So when I go to here, so let's say we start from this node and we go to this node. And when we go to here, there is nothing here. Because for this particular node, the two left and right child are null point. So which means that when we go to the left and we find out that I land upon a null pointer, means that I have nothing to be processed here on this left subtree, which means that I should just go back. Then I should go to the right hand side. Keep on going. Now, as you can see, for this right hand side, there is nothing. Then I again travel. So we'll first go to left hand side, left whole subtree, right whole subtree. Now, when we have traversed over the whole and right subtree, then we'll just print out the value, whatever way. That is what is. So this overall tranquility for this particular problem is also open because we are also traversing and touching all nodes. That's the complete logic and the code part for this particular problem. If you still have any doubts, you can mention in the comment box for this video. I will see you in the next one. Recoding and bye.